Hi guys, I'm here in the science classroom today to do a few experiments. They're made with things that you have at home. I'm hoping you guys can make one like this and you can share them with each other and try and explain exactly what's going on. And my dog Bramble is here. You want to see her? She's not too happy about it, but she's hanging out in the science class. And okay, I'll let her down. So there's three that you can choose from. The first is building this kind of balancing apparatus using whatever you have. It could be toothpicks like this. It could be these long skewers for the barbecue. But basically, make something that looks like this, and then try and get it to balance. So if you'll notice right now, it's just two pieces of sticks into a marshmallow. And if I try and balance the toothpick on my finger, it doesn't totally work. Okay, it kind of flips over. But if I add some weight to the end with these little Play-Doh kind of things, and I do the same thing, I can balance it perfectly. So it's pretty impressive how that happens, and I'm interested to know why. Okay, so that's one example there. The second example is if you take two forks. I've just got plastic ones because I'm in Beau Rêve and I couldn't find any metal ones, but the plastic ones will work. You kind of weave them together like this. Okay, and I'll see if I can get this to work. And if you take a cup, put a toothpick in through here, just so that it kind of stays. Kind of like, let's see, to make an adjustment here. Okay, kind of like that. Okay, then we're trying to get it to balance on the edge of the cup. And I don't know if you can see that very well. I'll hold it up. So it's balancing perfectly on the edge of the cup, just on that toothpick. Okay, if you have a different size toothpick and a better glass, it might work better, but you could make this one too. This is a pretty impressive trick to do. And the last one is the hardest one. I tried it for like the last 30 minutes and it's not going well for me, but basically you take a wire coat hanger and you stretch it out like this. It used to be like that, right, for hanging up coats. Stretch it out like this and try and get the coin, any coin, I have a 2 franc coin here, try and get it to balance on the end like this. And if you can, then slowly swing it back and forth, and eventually, if you're really good, better than me, you could get it to do a full 360 and the coin won't fall off the end, it'll stay. I've got a video of me doing it, but it took me like 40 tries and I was kind of getting tired. It was like 30 minutes or more. So that's like the expert level balancing trick. But all of these things run on the same kind of principle. Okay, the balancing here, why does that work? The balancing here, why does that work so well? And then why does it not work when I take the bottom weights off? Okay, but I want you to make your own kind of apparatus. I'll give you some links that give you some ideas, and share it with us and explain why this works, or why do you think this works? That's the goal of this. Okay, so good luck with it. Hopefully I can see your creations next week and we can talk about a few bits why it works and things like that. Okay, thanks. One last thing I wanted to talk about was the center of mass. So it's kind of the principle we're building on here is a bit of physics and a bit of like why do things balance perfectly. So this is a ruler. It's 30 centimeters long, and if I find the middle, which is about 15, at least on this ruler, yeah, 15. This is exactly the middle, and it'll balance perfectly. But if I shift my hand just a little bit to one side, you'll see that it's heavier on this side and it falls over. Same with the pencil. It doesn't have markings on it, but if I gently make adjustments, I can find the center of mass. It's not perfectly in the middle because of the eraser, but same idea. But what if I were to take something like this? The center of mass is definitely in the middle. You know, here it was actually like right here, 50% of the way. And same with the pencil, like I could see where the center of mass is. But on here, the center of mass isn't necessarily like right in the middle. It's actually here, but it's not part of the plastic, the roll of tape. So it's kind of in space. So if I could put my finger here, then it would balance perfectly. But obviously it doesn't because there's some space in there. So if I go here, is it going to balance? Well, not very easily. It might take me some skill, right? I've got to kind of shake around to find the center of mass and keep it balanced. But if I put my hand here, it's easy to keep it balanced. So that's what I want you to think about when you're building these balancing structures, is this similar kind of thing. Why doesn't it balance here, where the center of mass is up here in the middle, but why does it balance here very easily, where the center of mass is still in the same spot in the middle, but it's quite a big difference from this to this, okay? And maybe same with the soccer ball. You can think, if I were to balance the soccer ball on my finger, it's not easy, okay? It kind of wobbles around. The center of mass is right in the center of this ball, but it's not so easy to find it because my finger is below. If I were able to hold it above, it would hang no problem and it wouldn't wobble over all over the place. Okay, so that's just something for you to think about, the center of mass.